Hi, it's Coding Thursday with Fixie Security, and on today's episode, we're moving into the intermediate step in C programming, which features the backslash codes, headers, and various data types in C programming. After that, we then progressed in showing examples of a few of these data types and how they are implemented in C. So without wasting much of your time, let's get straight to today's topic. So backslash codes are common codes that are used in C programming. They denote or represent certain attributes or functions that you want the code to display. For example, the /a will ring a notification in the terminal. The /question, it's an ANSI character extension to display question mark at the end of a print statement if specified. The backspace is to give a backspace. The R is the carriage return, especially when you're writing programming codes that receive input from users. The /f is form field. The /t is for horizontal tab. So horizontal tab is like giving a spacing in the code before displaying the print statement or indicator if the code is accepting input from the user. The /o is for ANSI null characters. The double slash or double backslash is for single comments. If you're writing comments in C, using the double backslash would allow you to write a single line comment. Others are the /double quotes, the /single quotes, /n, which denotes a new line, and the /o for octal constant, while the /x is for hexadecimal constant. What are headers? So headers in C comprises of functions and macros which are good in performing input and output operations. They are required to perform standard functions in C, and without them, the compiler would throw a declaration error to either include the header or provide the declaration statement. So example of these warnings are like incompatible implicit declaration of built-in functions. So these are the various headers and their description. Assert.h is a standard library that is used to verify assumptions made by a program and print the diagnostic message, which determines if the program is false or not. We have the complex.h used in manipulating complex numbers, especially if you're writing mathematical equations. You have to include this header file or this header library to be able to manipulate a program to print out complex mathematical functions. So this complex.h comprises of a lot of functions in its headers library. And the Ctype is a standard library used in declaring several functions that are used in testing and mapping of characters. So basically, if you're writing characters or string data types, you can specify the Ctype in this will allow you to manipulate or declare these several functions and mapping characters to them. N.h defines integer variables that is set by a system to call some library functions in the event of an error occurrence to indicate what went wrong. And the rest of this are the fn-environment.h, the float.h, the inttypes.h, the iso.64h. So all these are the various header files. And as you write code, software, you build botnets or malware for testing, you will need these various headers to be able to manipulate the codes to carry out a specific functions. So the continuation of the header files, we have the stdbool.h. It's associated with the bool function, true or false, or boolean test. And we have the standard def.h, various types and macros. Many of these definition also appears in other headers. We have the std integer.h. This header defines a set of integer types aliases with specific width requirements, along with macros specifying their limits and macro functions to create values of this type. So there is the stdio, which is a standard library for input and output in C. This library uses what are called streams to operate with physical devices such as keyboards, printers, terminals, or with any other type of files supported by the system. For the standard library.h, this header defines several general purpose functions, including dynamic memory management, random numbers generation, communication with environments, integer arithmetic, searching, sorting, and converting. So especially when you're writing a lot of encryption algorithms needs to generate random numbers, you need this std library.h. For String.h, this is to specify string data types or manipulate strings and arrays. tgmaths.h includes headers for maths.h and complex.h. Remember, previously we spoke about complex.h to write complex mathematical formulas or equations, and maths.h is also for mathematical equation. So with tgmaths.h, together it's going to include the complex.h and maths.h, and it's a generic macros. So if you're writing a code and you don't want to exhaust your memory by specifying a lot of headers, you can just say tgmath.h, and that will include both the complex and math.h headers. And you can then now manipulate your code based on what you want your equation to be. So time.h header defines for variable types, two macros, and various functions for manipulating date and time. The wchar.h is for wider C strings. So you want to specify a wider C string, you have to use the wchar.h header. And the Ctype is also a header declares a set of functions to classify the transform of individual wide characters. Remember, we talked about Ctype.h, both for characters and string. With the Ctype.h, it specifies it to a wider range. It's good you know all these header files, because when we start talking about complex coding or writing complex examples while demonstrating this coding series, you understand that most of the programs or functions we'll be writing will comprise of these headers, because without these headers, there's no way our code will successfully execute. We either have the application or the terminal throwing back an error that this cannot be executed due to missing libraries or header files or declaration types. So know this is very important, and it's very good that you know this. I wouldn't go deep in describing this, but if you're really interested in getting to have this cheat sheet, do not forget to join the Discord, as we'll be pushing this to the Discord. It's one of the benefits for those who are in the Discord channel. So for data types in C are set of values a variable are to take or assign to, and the set of operations that can be applied to those values. So we have the primitive stroke basic data type in C, which is the char, which stands for character. Integer, we have the float, we have the double. So these various data types have their own characteristics. If you use char on a variable that is assigned a number which is supposed to be an integer, your code is going to throw error. Or if you use float, when you assign a variable a double value, then also your code is going to throw error. So it's basically, you have to understand these primitive data types. So when you specify these values, you know the data type you're going to assign to them. For characters, you know you have to assign char. And for single numbers, you know you have to assign integer. For decimal numbers, depending on the range, you have to assign either float or double. So for derived data types, these are basically like arrays, functions, and pointers, which subsequently we'll be discussing this in our paid courses and giving some snippet examples in the free channel on YouTube. Then for users defined data types, we have the structure. When you create the struct, we have the union, we have the enumeration. So these are user defined data types. And for non-value data types, or data types that do not require values to be assigned to them or return any value, it's void. So these are valueless and they are considered non-value data types. So range of data types in C for 16 bits and 32 bits computer as described. You can see the chart here. No need to explain this, it's just straight to the point. This is the range, which is the lowest to the highest, and this is to the lowest to the highest. So for 16 bits, character can take about 8 bits, both in 32 bits, also 8 bits. Integer is 16 for 16 bits, and for 32 bits, computer is 32 bits. Float is 32 and 32. Double is 64 and 64, and void is 8 and 8. Yeah, various range in 16-bit and 32 bits is described here, which we have specified that this value here is the lowest and this is the highest. Let's demonstrate a few examples for you to appreciate and understand what we are actually talking about here. So this online GDB. So to demonstrate this example, we're using this online tool or online compiler known as online GDB. It's a free tool. If you want to run or test a few small codes, I recommend you use this online tool. I've been using this for years, but if you are writing complex code where you have to include files and other things, so I think you need to sign up and check your projects, that which wouldn't be going here. Just visit the site, check on how you can use these tools. You can see here you can attach new file. If you create a new file, you specify the file, then you can now run the code. Basically, this is like when we are writing complex code that has different functions and we decide to, write this on different files, which is modular programming. So different models will contain different files. This is where we will now include the file. So if we say create this file, let's say we call this greetings.c. Let's see, we click OK. So you can see the file is already here. So this is our source code. This is the file. So we can specify here and we import it here. And whenever we call, the code is going to execute. So this is very straightforward. I'm not going to teach you how to use online JDB in terms of, debugging codes and writing your source code online. Just go through the tools and view the various menus on how to use it. So for instance, let's go straight. Today we are writing for C, right? Now, the basic, let's remove this. We know it's you guys, so let's not confuse people here. So let's say we want to declare a comment in C. We can say hello. This is a simple. Okay, let's say we want to declare a single line comment. We can say hello. This is just a basic learning from Cybersecurity. Now, single line comments are best practices when you want to describe, let's say in this code, right? We say, okay, this code prints hello world. However, if you want to describe a multiple line comment using this all the time, like this, it's cumbersome in the sense that it's going to require you to type the double slash each time you want to write the single line comment. Now, the problem about this method of commenting when you want to write multiple comments is that you might make a mistake of not including a double line, of not including a double backslash. And when you type the code, you notice your code is starting to have errors. And if you're exhausted, you might think it's your code, not knowing that it's just a mistake on the comment or where you made a comment. So this is where the complex line comments or multiple line comments comes in. You just specify this by doing /* and ending it with asterisk backslash. So whatever that is within this, doesn't matter how long it is, whatever that is within here will be commented out. So if we say hello, this is a good way of commenting, and we click enter and we run this right now. It doesn't matter, it's just gonna run hello world. Now let's make a mistake. Let's say here the single line comment, we made a mistake. We forgot to put the double line while we're typing because we're writing complex program. You'll see an error right now. You can see there's an error here. Expected expression before this. So it's indicating that this backslash, there's an error in this code, and there is an expression that is expected before this comment. And this is why it's always dangerous to use single line comments in writing multiple comments. If you just want to write a single comment describing a particular section of the code, then using a single line comment is better. But if you want to give a detailed description of the code, like this code takes value, then prints the value, then terminates the program. Then the best option to adopt is a multiple line comment. Doesn't matter how long the comment is, as long as it is within the forward slash and the backward slash of the multiple line comments, whatever that is written here will not be executed. And also, comments are for the back end of the code. On the front end of the code, they will not be displayed. So whenever you come across a code and you see things like this, don't expect it to be in the output. Basically, what this is trying to say is that, okay, this is a comment, and this comment is something that I need to know to learn what the code does. Now that we have gotten that out of the way, you can see this is the header file. So let's remove this and run the code now. You will see what's going to happen. You can see warning, incompatible implicit declaration of built-in function printf, built-in declaration mismatch. So the reason why this code is not executing and is throwing the raw code out of the program is because the header file that is required for the input and output stream to run or execute this code is missing. So basically, this is what your code will be displaying to the user that is trying to use this program. And this is dangerous, especially when you write a software or you write a tool. It can throw out the lines of codes of what your program is. And a hacker or a malicious attacker can now understand what this program does. And by that, exploiting a few commands to see how they can maneuver the program. So it's always good each time you're writing a program, include the necessary header files, understand the concept of what you're writing, and do not include unnecessary headers as well, because that will also take memory in the program. So to include a header in C, you click the hash, you say shift hash, include. Then you say less than, then you specify the header you want to include. In this case, we want to include stdio.h, then you close. Now, if we run this program again, you can see hello world has been printed and there's no more error. It's imputing the code statement and not the source code or the raw code itself. So these are the importance of headers. Without headers, your code would definitely have some glitch, and in the hands of a bad guy, they will understand the source code or the back end of your software program or tool. Now let's take this to another level. Let's say we want to print a string type. We say, okay, let's start with string, let's say char, to print a character, right? And we call this character to be fix it, and we specify it to be an empty array because we want to increase the character. Then we say we are committed to teach you the basics. At the end of every C program, whether you're specifying data types and assigning value to them, you must end it with a semicolon. That's one of the complications or complexities of C. It's not like Python. Python, you can just declare the variable name and just put it in code, and that's it. You don't need to end with semicolon. But in C, you need to specify the semicolon. Now, if we come down here and we say print F, then we say this is our goal. Then we say, okay, let's use the slash T, the backslashes command, and we say comma, and we specify fix it. Now you're going to see the error that this code is going to throw. We say run. You can see now it throws the raw code or the source code of our program. So when I come across this type of code as a hacker or pen tester, I'll say, okay, this code here is printing their goal, and the goal is assigned a variable name called fix it. And the data type definitely will be string, but I believe there is something missing here, which is the header. So I would say in my mind that, okay, how can I understand what this code is doing next? Or how can I manipulate this thing? And these are one of the dangers of not including the header. It is required to execute a specific variable name data type. So whenever you assign a variable name a data, always include the header that is responsible in executing that data type. If you do not include it, then there is a problem. And this is where your program either crashes or exposes sensitive information to a malicious hacker or person. So we can do this in two ways. We can either use string or we can either use Ctype. So if we say include, remember, to include the header, we use hash include, open bracket, and we say Ctype, then .h, and we click this. Now, if we run this right now, you're going to see that this would run smoothly. I made a mistake. Ctype. So these are various ways of how to know when your program is having issues, then how to debug code as well. So you can see this code is this, and we're still having this issue, right? It's okay. Let's go back. Now, this is another thing again. You see, when you're writing code, if you're not good at writing code, you would definitely have a lot of issues. Now, if you look at this code, when we run this, do you notice there's an error again? Now, the reason why this error is existing is that because we did not specify the data type character in the print statement. So to make sure this executes properly, we come here, we say %s. So what are we trying to say is that this is a string and print the string. Without specifying the string, we'll still be having this our source code or our raw code being printed to the user in the front end of the program. So when we run this again right now, we should not have this error. And as you can see, hello world, this is our goal. We are committed to teach you the basics. So this is basically how you should understand the fundamentals. Because we understand the fundamentals, we can be able to debug each stage of our program. Whenever we experience an error, this is where the error is, because we know the fundamentals. Without the fundamentals, we'll just be debugging our program blindly. First of all notice that the Ctype.h, we misspelled it and we corrected that. Then when we try to print the program again, it threw another error, and we try to see where the error is, and we discovered that we did not specify that the output of the program is a string data type. So what did we do? We fixed it and we printed it, and our program successfully executed. So if we want to beautify this also, we can use the other / command, which is A, and you're going to notice there will be a beep sound after printing this program. And okay, let's put this /n. Okay, and we run this program. So you can see the sound beep right now and say, hello world, this is our goal. We are committed to teach you the basics. Programming, it's not complex. It's not difficult. Just understand the basics, how it's applicable. And with that, you can write your code, and you can write, not just write your code, you can write a sweet code. Now let's take this further. Let's say data type, right? Let's say integer. Let's call it q1 equals to 4. And remember, we close it with this, right? And we say printf the integer spelling data type is /t, and we just say q1. And we don't forget to put this, and we run again. Now you can see something right now. We do not specify the data type characteristics. Here we specified %s, but here we did not specify %d. So for integer data type, you have to specify %d. And that's why our code is throwing this error. So when we say %d and we run the program again, we should have a clean code right now. And as you can see, there is a 4. So let's make this into a new line to beautify the program. And we run. And as you can see, the integer data type is 4. So what is this code doing is, right, this print is just a gibberish statement we want it to print, and it's in quotes before printing the variable which we assigned a data type integer and the number value to be 4. So this is just the fundamentals, the basics. The moment we start writing complex codes, the moment we start writing codes and writing tools, you are going to appreciate knowing these fundamentals. So whenever you see a function or whenever you see a conditional statement, you understand, oh, we are comparing this variable name, which has a data type specified in the code, to another variable name, which has a specific data type also specified in the code. So complexities in code is just because people do not understand the basics. I cannot emphasize so much on this. It's good to understand the basics. Once you understand the basics, manipulating code, writing software is very, very easy. The basics are not just the headers as well. They're how to comment, how to terminate or end a specific variable name or data type specified, how to terminate a series of commands. For C, as we know, also in C++, when we get there, has a semicolon to terminate each lines of code. Without the semicolon specified, the program would not execute efficiently. Using different programming language like Python, we previously discussed Python, you don't need to specify semicolon. You just have to just write the code, assign the variable name. Python is like English language. So you just say, okay, I want this to be a variable name and I want this variable name to bear this value, and that's it. So once you print the variable name, it's going to print that value that you assign to it. But for C or C++, you have to not just specify the data type, you also have to specify the variable name. Then you assign a value to that variable name. So, okay, let's take this program to a more complex type. So let's say we say float. We call it a variable name of Thursday. And we call it to be 4.5678, right? And we come here, we say Thursday, and we run this. Oh, sorry, you have to put a semicolon, and we run this. You can see now it's printed 4.568, then added 0. Now let's say we want it to print only in 2 decimal places. So we specify that 0.2f is going to print 4.46 by rounding up these two numbers to 2 decimal figures. So let's run this again. And as you can see, it printed 4.46. Now, assuming we want to specify a long range of numbers, assuming we want to specify a long range of decimal numbers, we cannot use float. This is where double comes in. So if we say double, okay, let's leave this. Now let's call double, and we call it tools equals to 4.893245, whatever number, just call it 3, and we put semicolon, and we'll say printf, print the doubles, then we specify %f. Remember, %f is used for printing float numbers and doubles, so we can say print tools, right? And we terminate it with semicolon. And remember to beautify the code to always specify a new line so you can understand what your program is doing. So now if we run this right now, you can see there is a problem. Printf, not printf, printf. So we run this, you can see right now we have 4.893458. So if we say double here right now, let's say double, and we say, okay, we want it to be in how many decimal points? Okay, let's call it 0.7. Now we want it to be, you can see it's already truncated it, right? And we run this. You can see 1, 2, 3, 4, 5, 6, 7. Let's say we want it to be in 8 decimals. We say 0.8 and we run this. You can see 1, 2, 3, 4, 5, 6, 7, 8. Let's make it to 10 decimals. Let's see. And you can see 8 has been rounded up to 1 because 8 is greater than half. So basically, this is how you use float, doubles, characters in C programming. The reason why we are pushing you through these fundamentals, like we said, is for you to understand this basic so that when we start writing more complex codes, like, okay, this is what the code is doing. And you will not just understand the code, you also try to appreciate it and think deeply of what you want to build using this foundational knowledge. It doesn't matter, it cannot be just building a network scanning tool. It can be anything else that is just outside the box that you think that is very, very essential, that is required in the industry. And that is why we're teaching you the basics and the fundamentals. Now let's take this to another type of string data type. So let's say we want to specify, okay, let's call the string. Sorry, let's not make a mistake. Let's call this char. Or we can just continue with this char. We can say, okay, char. Okay, let's just comment this out on it so you don't get more confused using a lot of char. Fix it. So you can see the beauty of a single line comment, right? So we just put this and this single line will be commented out. And if we run this program right now, you will see something. Okay, that means we need to refresh this page. Whenever you experience this, like, it's just refresh the page. It's normal. And we run this, as you can see. So fix it is gone, right? So assuming we want to print data types by indexes, right? And we do not want to complicate our program by writing a lot of codes, making it more difficult to understand. We can say, okay, let's specify this. We say, okay, character, ending the program, ending, and we say this character should carry straight not more than 7 values of arrays. Yeah, let's just make it 7. Then we can now say ending index of 0 to be equals to we, ending index of 1 to be e. Remember to always terminate your program with a semicolon. Ending index of 2 and ending index of 3 . So now we specify 7 here, right? And if we say print f, remember we are printing, remember characters are strings, so we specify %s. So we are printing the ending. So let's say we just say ending. See what's going to happen, right? And we put this in a new line so you understand what we are doing. So we say run. As you can see, it's printed ending, WEAR, where. What this implies is that once we print ending, as long as the array index we specified has not exceeded this number, it's going to print it out. Now let's make something funny. Let's just reduce this to 4 and let's introduce 1, 2, 3, 4. Let's introduce another index. Let's say ending. Let's say 4 equals to R. Now let's say ending 5 equals to N. Let's just specify this. Now if we try to run this program right now, since it exceeded this number, we will definitely have an error. So let's run this program. So you can see stack smashing detected, terminated. So what this program is trying to let us understand that in the stack of the program, we specify that ending should not exceed 4 arrays of various indexes, of course, which is 0, 1, 2, 3, 4. But it's detecting that we have 5. So what's going to happen is that it will terminate the program and say, hey, the stack is incorrect, in the sense that you declared 4 and I am reading 5. So what's happening? So let's say we comment this out and we run the program again. You can see again, because in arrays, 0 index is considered as the first value. First index is considered as the second value. Second index is considered as the third value. So when you specify that, okay, I want the data to be 4 array indexes and I'm giving 5 values or characters, what it's going to read is that from 0 is considered as 1, 1 is 2, 2 is 3, and 3 is 4. So now anything outside this is an error. So to correct this thing, let's say we comment this out and we run this program right now. And as you can see, it printed where. Now let's make it this way. So let's say we want to put this order 2, right? We just call it 6, right? 0, 1, 2, 3, right? Yeah. So we call it 6. So that means, no, we call it, is it 6? Okay, wait, 1, 2, 3, 4. Yeah, we call it 6. And we end at 5, right? Yeah, good. So if we put this right now, everything is going to print. And I'm saying wearing. Now, even if we increase this to 20, there will be no stack error. It's going to print because this array indexes of this individual endings we are printing, it's within the range of 20. So it's not exceeding 20. So the program is going to say, okay, fine, I can still print this. It's not exceeding the master code or the master array. So if we run this again right now, you will see it's still going to print it. And if we increase more arrays into this index 6, index 7 until index 19, it's going to print it. But if it gets to index 20, now it's going to be 21. We should specify here. So anything outside that is going to say, oh, this is an error. I am not printing this. There is a stack smashing error, so I'm terminating this program. Now, the last part of this program, let's say we want to print from index. So let's say we want to print from index 2 downwards, right? And we want to ignore index 0 and 1. So we can say printf. We are going to print the indexes aside 0 and 1. And remember, it's a string, right? We say %s. Now we say comma to print the address location. We say end. And we specify from where? From 2. So we say ending index of 2. That's simple. There's nothing there. There's nothing complicated about this program. So what we are telling this program right now is to ignore 0 and 1 and start printing any value from index of 2 downwards. And if we click run, Let's put this in a new line, so our program will be beautified. And if we click run, you can see now it ignored 0 and 1. It started printing from 2, so it's AREN, AREN. That's how simple it is. Programming is not complicated. The only problem is that most times people do not understand the fundamentals, and they see a code that is written and like, oh, programming is too hard for me, because you do not understand the fundamentals. When you see codes, you start feeling like, oh, these are complexes, or the people writing these codes are geniuses. They understand the foundation, they understand how this code works, and they understand how they can manipulate these various concepts in terms of headers that needs to be included, in terms of defining functions, structs, iterations, different types of conditional statements like for, while, and so on, if and else statements. So because they understand these fundamentals, they can now write a code as robust as 600 million lines of code, 10 billion lines of code. All they just need to do is, while they are writing these codes, they specify comments of each lines of the code or each files of the code, what it should be doing or what it does, so that even when they make reference to it, they understand what this particular line of code should be doing, as they are the ones who wrote those codes and they know the foundational skills or structure of the program. They know when they import a header or library in terms of Python, they know what this particular library does. So anywhere they see the usage of this library function, they understand this is where this library is applicable, or this is where this header is applicable. So that's it for this week. There's nothing complex about writing codes. The only thing you need to know is to understand the basics, then knowing the various data types. After that, knowing the types of headers that needs to be included when writing a specific line of code. Understanding how you can assign these data types to a variable or variable name, how to terminate these variable names by semicolon after they've been created, how to print the various statements, what are the characteristics or features that needs to be specified in the line of code that prints out the output of the statement. And for this course material, we'll be putting it in Discord. These are the benefits of joining the Discord. So I urge you to join the Discord. I wouldn't be posting this on Twitter or LinkedIn or Facebook. It's going to be strictly on the Discord. So those that are in the Discord, although they are not much at this moment, but these are the benefits they will have. They will have this material and further cheat sheet. I'll be building a cheat sheet which will be coming out by end of next month of these various headers and their applications. It's going to be a long page and I'm giving it out for free. I'm not charging for this. I'll build a cheat sheet so that you can always make reference to this, understanding how it works, where it's applicable, why you should include it. It might be more than 30 pages, but definitely those in the Discord will have the benefit of getting this firsthand. You should join the Discord because more good stuff are coming. We are geared up for the year, like I said, and not just tools we'll be building, a lot of tips we'll be sharing as well, not just our followers, but also for those in the Discord channel. So join the Discord. It's a good place to be. Make it interactive as you join. Please follow the rules. Do not do any religious campaign or crypto stuff. We're not into crypto. We're just strictly cybersecurity and tools and trainings. So whatever group that is open for people to communicate, please just stick to that. It's not a pleasure for you to join where you're supposed to learn something good and you're banned, because once you're banned, we wouldn't unban you. You'll be kicked out from the Discord channel for life. We are not here to promote businesses. We are here to train people on cybersecurity and other information technology trainings. Join the Discord, like I said, and get to learn a lot of good stuff. So we have come to an end of this week's episode, and we hope you have learned something new on the tutorial taught today. Please do not forget to give us a like by pressing the thumbs up button, subscribe by tapping that subscribe button, turn on the notification bell by clicking the bell icon to be the first to get notified when we publish our next video. Thank you for watching, and bye for now.